Hi guys, in this video, I'm going to finish this chapter 3. We left the demand side and the equilibrium, so let me cover that part. So here, you need to recall the equation that I gave you before in chapter 2. So the output equals the consumption plus investment plus government spending. So we're gonna study the one by one. So let me start with the consumption. So consumption is a function of the disposable income times the MPC, which is a marginal propensity to consume. So actually, let me fix this one. So I prefer to write down consumption is the MPC times the disposable income because this one is confusing whether it's a consumption itself or the MPC. So that's why I prefer to replace this consumption with the MPC. Now, what is the disposable income? So for example, when you get a job, let's say that the company offers you $1,100 per month. So that's the Y, your income. But then when you receive the check, it's $1,000 only. What happened? Because they deduct the tax before you receive the check. Okay, so Y minus T is your disposable income, which you can spend on it, right? And then here we need to multiply the MPC. What does it mean? So when you make the $1,000 as a disposable income, you cannot spend in general, you don't spend the $1,000 everything, right? Because you spend like a 70%, 80%, something like that. That's the MPC, marginal propensity to consume. So for example, your MPC is a 0.8 and your disposable income, Y minus T, is $1,000. In that case, your consumption is an MPC times a Y minus T. That is a 0.8 times $1,000. Then you have $800. So your consumption is $800. Okay. And then you can represent with the graph. So the y-axis is consumption and the x-axis is disposable income. Since the consumption is MPC times a y minus t, this is an x variable and this is a y variable, and this MPC is a coefficient. And MPC is a less than 1 and between 0 and 1. That's why it's less than 45-degree line. I mean, the slope is a less than 45. So why the MPC is between 0 and 1? So first, you cannot spend more than your disposable income. That's why it's less than 1. And then it's greater than 0. That means that you spend something, right? You don't save everything. From there, you also get to know MPC plus MPS is equal to 1. Why is that? You, as a consumer, either you consume or save. So marginal propensity to consume plus marginal propensity to save is equals to 1. Okay. So for example, let's say the MPC is a 0.6, your marginal propensity to consume is a 0.6, then automatically marginal propensity to save, MPS, is a 0.4. Okay? So that's the consumption. Let's go to the investment, second component. So investment is a function of the real interest rate, and you can find the inverse relationship between the interest rate and the investment. Okay. So investment negatively depends on the real interest rate. The reason is following. Well, the real interest rate is the cost of the borrowing. So when you start a business or when you try to have a new project, something, then you need to borrow the money. That cost, that is a real interest rate. When you borrow the money, you need to pay the real interest rate. But when you realize that real interest rate high, so then you have a burden to pay back this real interest rate, or you hesitate to invest your money into you hesitate to borrow the money because of this high interest rate. That's why it gives you the inverse relationship. On the other hand, when the interest rate is low, you have no burden, so you can borrow the more money and you invest more. And also you can draw the graph like this. So y-axis is the real interest rate, x-axis is the quantity of the investment. Since it captures the inverse relationship, that's why you have a downward sloping investment curve. And then the last component is a government spending. So we covered in chapter 2. So government spending, that's the fiscal policy variable, and this is the exogenous variable. This is determined outside the model. And the text is the same. It's determined outside the model, so that's why the T and G are exogenous variable, and that's why we put the bar. Okay? The reason that we make it exogenous is to make it simple. Okay? Now we put it together because the first part we studied about the supply side, and now we covered the demand side. Okay, so MPC times the disposable income, that's the consumption plus investment plus government spending. So the right-hand side is a demand, and then the left-hand side is a supply. Like I told you, we made an assumption this is a market clearing model, so demand equals the supply, then we can have the equilibrium. But you notice that there's only one variable which is not determined yet, and which is determined inside of model, that's the real interest rate. So that's why the real interest rate adjusts to equate demand with the supply. So that means that demand equals supply, we have this equilibrium, this equality holds. Now let's talk about the last market, the loaner funds market, which is the last part of this chapter 3. So this is a hypothetical supply and demand market for the financial system. And then there's a one-on-one asset loaner funds. And this demand for the loaner funds comes from the investment. So the companies, when they start a new business or they have a new project, then they need to borrow the money and they go to the loaner funds market and they borrow the money. On the other hand, the supply of the funds comes from the saving. It comes from the household or it comes from the governments. So if from the household, we call it the private saving. And when it comes from the government side, that we call it the public saving. All right, so we can draw the graph. So loaner funds demand is the same as investment because companies wants to borrow the money through this loaner funds market to invest. So that's why we have a downward sloping demand curve for the loaner funds. Again, the interest rate is high. You have a burden to borrow the money, so the demand is very low. When the interest rate is low, then you have no burden, or you have a very small burden to borrow the money, so that's why you borrow a lot. Okay. On the other hand, the saving is a vertical. We're going to cover that one in the following page. So let's talk about the saving. So private saving as a household is a disposable income minus consumption. That's the leftover. Okay? And then the public saving is a T minus G. T is a government's income and the G is their spending. So when T is greater than G, we call it the budget surplus, and that's a public saving. Of course, a public saving could be negative when they spend more. Okay? And then the national saving, put it together, private saving plus public saving gives you the national saving, and you realize that these taxes are cancelled out, so that's why the saving equals Y minus C minus G. Okay. And then you see that here, this saving does not have the interest rate, right? So that means that the interest rate does not, so this saving does not depend on the real interest rate. That's why here the saving is a vertical, okay? Now move on here. Okay, this math concept is very important to understand the following. The concept here, the delta is a change in X, and take a look, this one. Delta Y and minus delta T, so that means that you can distribute this delta, and then consumption, as you know, MPC times the disposable income, and you can put the delta like this. Then you may ask me, why didn't you put the delta in front of the MPC? Because the MPC is constant, while the C, Y, and T are the variables. One more time, C, Y, T are variables, but MPC is a constant, like 0.8, 0.7 something. Okay? So that means that we don't need to put the delta in front of the coefficient, constant. Okay. Now this one is very important. That's why we studied the notation delta, change of variable. Well, let me start with this equation. So saving equals a Y minus C minus G, Y minus MPC times the disposable income minus government spending. You can rewrite down the 1 minus MPC times the Y plus MPC times the T minus G. Of course, you can put the delta by using the previous slide. So delta S equals 1 minus MPC times the delta Y plus MPC times the delta T minus delta G. Okay? And if there is no mention about the variable, so that means that you can assume that there is no change. So for example, the first one, delta G equals 100, that means that delta Y equals 0 and delta T equals 0. So you just need to plug in the numbers into the equation, then delta S is 1 minus MPC times 0, MPC times 0, minus delta G, that is negative 100, okay? That makes sense. If the government spend more money than before, so in this case, they spend $100 more than before, then the national saving is decreased by 100. Okay. Now the second one, so delta S equals the MPC times the delta T, and MPC is given as 0.8, so 0.8 times 100 is 80. So when government collect the tax by $100 more, then the national saving is increased by the $80. And then the third one, delta S equals 1 minus MPC times the delta Y, because delta T equals 0, delta G equals 0. Okay. Then in this case, 1 minus 0.8 times 100 is 20. So when output is increased by 100, then the national saving increased by 20. The last question is a little bit tricky because you need to recall the marginal per labor. So marginal per labor by definition, delta Y over delta L. So when you have the one additional worker, how much it affects the output. Okay, so that's the MPL. And you can rewrite down delta Y equals MPL times delta L. Since the MPL is given as 20 and the delta L is 10, so you see that the delta Y is 200, then it's same as our question number C. So delta S equals 1 minus MPC times the delta Y. So 1 minus 0.8 times 200 is 40. Okay? So when you hire 10 more workers, then the output is increased by the 200. When the output is increased by 200, your saving is increased by 40. Okay? And this one we already covered before. So when the tax is greater than government spending, then budget surplus. Tax is less than G, budget deficit. When they are the same, balanced budget. And here's the data. Most of the time, this is below 0. That means that most of the time we face a budget deficit, but there are few periods the governments face a budget surplus. And then when you have the cumulative one, that's a debt. So debt is a start and the deficit is a floor. And over time is a keep increasing. And loan over fund supply curve, again, since we study about the saving, and saving does not depend on the interest rate, that's why it's a vertical. And together with the demand, so we can find the equilibrium real interest rate. Okay. So, for example, what if COVID-19 hits the world and no one wants to invest, or everyone withdraw their plans, then investment should be decreased, like shift to the left. And in the case, real interest rate is decreased, or we recover from the COVID-19. COVID-19 is gone, endemic. So then everyone has a bright future. They think that this is a moment to invest. And in the case, investment is a increase, right? So then we're going to have the higher interest rate. Okay. All right. So you can read this part. So the things that I don't touch, that means that it's in general, it's easy to understand, or I leave it to you that you study by yourself. Okay, this case study. And by having this study, you get to know why we need to study theoretical models. Okay, so the Reagan deficit policies during all the 1980s. In fact, they spend more, so the delta G is an increase, but at the same time, they cut the tax, and this one we call the expansion of fiscal policy. They spend more money, but they collect less taxes to mitigate the recession or to boost the economy. Okay? Now, because the government spend more money and they collect less taxes, national savings decrease, right? Then what happened? The model predicts, well, if the government spends more money than before and they collect less taxes than before, then national savings decrease. As a result, we expect that real interest rate is increased. Okay? That's what model predicts. And the question is, this model is working well? And the answer is yes. So from the 1970s and 1980s, you see that the T minus G is increasing in absolute. That means that we face more deficit than before. And as a result, the national saving is decreased as we predicted through the model. So saving is decreased, saving shift to the left. And then as a saving is decreased, as a result, the equilibrium real interest rate is increased. Yes, this one matches with the data. And like I told you, real interest rate and investment, they have an inverse relationship. Real interest rate goes up, investment goes down, and yes, it's working. Okay. All right. So this is what I mentioned before. So for example, if there's an increase in investment demand, then as a result, we're gonna face higher interest rate. And of course, you can think that, well, it doesn't make sense why the supply curve is vertical, because when the interest rate is increased, then household or the governments, they have an incentive to supply more disposable funds because they can have the higher interest rate, okay, by saving. From the saving, you get more interest rate. So that's why we can relax that assumption. If we relax that assumption, then we can have the upward sloping. But the result is pretty much same as before, except the amount of the increase. Okay, so when investment is increased with this upward sloping supply curve, then in that case, this increment of the investment, the equilibrium of the loan funds increase more than before. Okay, so that's the only different thing. Other than that, the result is pretty much same. All right, so let me stop here.